Hello students, welcome to the third part of our chapter Atoms and Molecules. Okay, atoms and molecules. So in the last two parts we discussed the theory parts of this chapter atoms, atomic theory. Okay, Democritus, one of the scientists we familiarized. I think you can remember all. And also what is atomic theory, then Dalton's atomic theory, and then what is mole concept, atomic mass, molecular mass, how to write the chemical formula of a compound. Okay, so many things we discussed in the last two parts, right? Now, I think all of you studied the chapter well, and it is time to practice our questions given. Okay, so in this part we are going to discuss the questions given in your exercises. Okay, so going to the first question, that is, as you can see here, a balanced chemical equation is in accordance with we know a chemical equation. What is a chemical equation? Chemical equation can be used to represent the chemical reactions, right? Several chemical reactions are there. Lot of elements will combine together to form several compounds. So is it possible to write all these chemical reactions as words every time? No. We know it is not possible. It will be difficult, right? So we are using some symbols for writing the chemical equations. So while writing a chemical equation, which of the following law is obeyed? They are asking. A balanced chemical equation is accordance with. Balanced means left hand side and right hand side of the arrow mark should be equal or balanced. That will be in accordance with. That is what the question asks. First one is Avogadro's law, second one is law of constant proportion, and the third one is law of conservation of mass and law of definite proportions. These are the three options given. We all know what are these four laws saying. Okay, so definitely a balanced chemical equation should be accordance with the third option, that is law of conservation of mass, right? Law of conservation of mass. This can be the answer option, law of conservation of mass. We know Avogadro's law. Avogadro law, equal volume of all gases under similar conditions of temperature and pressure contains same number of molecules. That is not representing any chemical equation. Law of constant proportion, that means each and every compound contains same elements combined in definite proportions, right? Also law of conservation of mass represents what? Mass of reactants and the products should be equal. Okay, that is what we are considering while writing a chemical equation. Okay, chemical equation. Law of definite proportion is also same as that of law of constant proportion. These two are the same laws. Okay, so here the answer option is law of conservation of mass. Mass of the reactants and the mass of the product should be equal. Okay, so that is the answer of the first question which we have. Okay, now going to the second question. What is the second question? Two elements, you can see here, two elements X and Y combine in gaseous state to form XY in the ratio 1:35.5 by mass. The mass of Y that will be required to react with the 2 gram of X is. That is the question here. So here two elements are considered, right? X and Y. They are combining together in gaseous state to form XY. So our elements are X and Y are the elements here. They are combining to form in gaseous state and forms a compound XY. So the reaction is what? X plus Y gives XY. Okay. In the ratio 1:35.5 by mass. That means mass of X is to mass of Y is equal to 1:35.5. Okay, 1:35.5. This is the ratio of their masses. Then mass of Y that will be required to react with the 2 gram of X is. So from this ratio, it is clear that during this reaction, mass X stands for 1 gram. Okay, mass of X is 1 gram, no doubt. Also, mass of Y is equal to 35.5 grams, right? So they are asking what is the amount or what is the mass of Y that is required to react with the 2 gram of X. From this expression, it is clear that for 1 gram X, how many grams of Y is required? Yes, 35.5 gram Y is required, right? Required. Therefore, for 2 gram X, if X is doubled, amount of X is doubled, then what will be the mass of Y? Then Y is equal to how much? 2 into 35.5. That is equal to 71 grams. Okay. So, which will be the answer option here? Yes, it is 71 grams. Okay, 71 grams. Our option D will be the answer option. I think you got it. Now, going to the third question. Okay, third question. Which of the following is not correct postulates of Dalton's atomic theory? We know Dalton's atomic theory. John Dalton proposed atomic theory, right? So, these 4 statements are given. Among these 4 statements, which is not correct? Okay, which is not correct in accordance with Dalton's atomic theory? Not correct. Incorrect statements we have to choose. Okay, first option is what? Atoms of this given element are identical in their mass. Sorry, the first option is right. All matter is made up of tiny particles called atoms. Okay, all matter is made up of tiny particles called atoms. Yes, it is a statement said by who? Our John Dalton in his atomic theory. Of every matter, if we are dividing matter into smaller particles, then we will reach a finest particle, a smallest particle that is no more divisible. These are the words by John Dalton. So, all matter is made up of tiny particles called atoms. This is the first statement that is correct for Dalton's atomic theory. So, it is correct, right? Now, atoms of the given element are identical in mass. Yes, for a given element, the Dalton said that for a given element, its mass will be identical. Okay, atoms of the given elements are identical in mass and all aspects, he said. But this was a wrong statement. Later, the identification or the isolation of isotopes, this statement became wrong. Okay, but it is said by Dalton's atomic theory, so we can choose it as a right statement. Atoms of different elements have the same masses and same chemical properties. Is it possible? No. According to Dalton's atomic theory, he said the right statement as B. Okay. Atoms of same element are identical in mass, but atoms of different elements are different in all aspects. So, here in this third statement, they are saying atoms of the different elements have the same masses and the same chemical properties. That is incorrect. Never it will be possible. Okay, atoms of oxygen, atoms of hydrogen, atoms of carbon, atoms of nitrogen. If we are considering, all these atoms will be having different properties, right? So, our answer option will be C. And the fourth option is atoms combine in the ratio of small whole numbers to form compounds. That is also correct accordance with according to Dalton's atomic theory. So, all statements except C are correct for Dalton's atomic theory. So, answer option for our third question will be C. Okay. Now, going to the fourth question. A sample of ammonia molecule, irrespective of source, contains 82.35% of nitrogen gas and 17.65% of hydrogen gas by mass. This data supports. Okay. Suppose we have ammonia molecule, NH3 molecule. In ammonia molecule, they are saying a sample of ammonia molecule, irrespective of the source. That means from where it may be produced. Okay, that doesn't matter. Okay, any source we can consider. Irrespective of the source means independent on the source. That means any source we can consider. Okay, so irrespective of the source contain 82.35% nitrogen. They are saying nitrogen is equal to 82.35%. And hydrogen, yes, hydrogen is equal to 17.65%. Okay, by mass. This data supports. That means, according to this data, they are saying in a compound, here it is ammonia, in any compound, the combined elements will be in a definite proportion by mass. Okay, that is the law behind this which law is supporting this data, they are asking. First one is law of conservation of mass. Is it law of conservation of mass, law of multiple proportion, Avogadro's law, law of definite proportion? Yes, it is definitely the fourth option, right? Law of definite proportion. Why? Because this data is saying that irrespective of the source, every time ammonia is containing nitrogen and hydrogen in this percentage by mass ratio. Okay, so this is in accordance with the law of definite proportion. The hint is irrespective of the source, okay, from where it is getting. That is not a matter. Ammonia may have is definite amount of hydrogen and oxygen. Okay, there are various ways for the production of ammonia gas. That doesn't matter. Every time ammonia molecule may contain hydrogen and nitrogen in this percentage. That is what saying in this question. And so this data supports law of definite proportions. Okay, so we are going to fifth question. Molecular mass is defined as the molecular mass. What is the definition of molecular mass? First option is mass of one molecule. Molecular mass is the mass of one molecule of any substance compared with the mass of one atom of carbon 12, mass of one atom compared with the mass of one atom of hydrogen, mass of one atom compared with the mass of molecule, mass of one molecule compared with mass of one atom of nitrogen. So which may be the correct option regarding molecular mass? So among these options, we have to choose the elements with which we are comparing the mass of a particular molecule. So we know that it is carbon 12. So in the first option they are saying mass of one molecule of any substance compared with the mass of one atom of carbon 12. That means mass of one atom of carbon 12. That is actually not completely correct. But as it is given as carbon 12, we can choose it because in the remaining options we can see other elements. Mass of one atom, mass of one atom. They are asking molecular mass. Here it is given as mass of one atom. That is atomic mass, we know, as compared to the mass of one atom of hydrogen. That is not correct. Mass of one atom compared with the mass of molecule. So that is also not correct. It is clear. Mass of one molecule of compared with the mass of one atom of nitrogen. So all these three statements are incorrect. Definitely incorrect. Because they are asking about atomic masses or they are comparing with any other elements other than carbon 12. So in the first option only, mass of one molecule of any substance compared with the mass of one atom of carbon 12, or actually it is 1/12 mass of one carbon 12 atom. Here it is one atom of carbon 12. We will take 1/12 mass of carbon 12. That is the difference here. But the most appropriate option for this question is first option. Okay, so answer option A will be for question number 5. Okay, now going to sixth question. Which of the following is not an element? Which of the following is not an element? Okay, first one is diamond. Is diamond an element? Think. Second one is graphite. Is it silica? Then ozone. Okay, which is not an element? We know that element may contain similar type of atoms or atoms of same elements, atoms of like similar properties, right? But a compound may contain atoms of different elements with the different properties. Okay, so here diamonds and graphite, these two are allotropic forms of carbon. Okay, these two are allotropic forms of our element carbon. These contain only carbon atoms. No any other elemental atoms are there. So these cannot be compounds. Also, silica means silicon dioxide, SiO2. Silicon dioxide. Here it is clear from this formula that the silicon and oxygen atoms are present there. So as it is a combination of two different elements, silica can be considered as a compound and it also can be considered as our answer option. And also ozone. Ozone is actually O3. That means 3 oxygen atoms are combined together to get ozone molecule. That is an allotrope of oxygen. Okay, so here it is carbon, and it is oxygen. So our answer option is silica, the third option. Okay, now going to 7th question. An atom is 20 times heavier than 1/12 mass of the carbon 12 atom. The atomic mass is. An atom is 20 times heavier than 1/12 mass of a carbon 12 atom. The atomic mass of carbon is. Atomic mass of that element is. So, what is the definition of atomic mass? Can you say? Yes, it is the number that represents how many times an atom of an element is heavier than 1/12 mass of a carbon 12 atom, right? So, we can choose an atom is 20 times heavier than 1/12 mass of a carbon atom. Suppose we are comparing the mass of an atom with the 1/12 mass of a carbon atom, then we got it is 20 times heavier than 1/12 mass of a carbon atom. Then no doubt its atomic mass can be considered as what? 20. Okay, 20. That is the definition of atomic mass. Okay, that is an atom is how many times heavier than? How many times means here it is given as 20 times heavier than 1/12 mass of a carbon 12 atom. 1/12 mass means what? 1 AMU. Okay, we know. So answer option will be 2 or B for this question. And now going to 8th question. We are going to 8th question. So, which of the following statement is not true about an atom? They are asking. These statements are given related to an atom. Which among these statements are incorrect? That is what we have to choose. Okay. Atoms are the basic units from which molecules and ions are formed. That is a correct statement, no doubt. So, we can consider A as the correct option because we know that atoms are the basic units from which molecules and ions are forming. Molecules are the combination of 2 or more atoms of same or different types. So, atoms are the basic units for the combination or the formation of molecules, right? Only by the combination of atoms, molecules can be formed. And also ions. Ions are obtained as a result of addition or removal of electrons from an atom. Okay, so atoms may be changed or converted into ions also. So, atoms are the basic units from which molecules and ions are formed. That is a correct statement. Second one, atoms are always neutral in nature. Yes, we know that inside an atom, there are protons and electrons. These are the only charged particles inside an atom. These two particles are having equal magnitudes of charges. That means these are equal in number. As positive and negative charges are equal in number, we can say that atom is electrically neutral. So that is also a correct statement regarding atom. Atoms of most elements are not able to exist independently. Yes, no doubts, we know. Atoms, almost all elements are existing in combined forms. Only few elements are existing as free form. So most of the elements, atoms of most of the elements are existing in combined forms because they are unstable. So atoms of most of elements are not able to exist independently. That means those elements which are able to exist independently may have 8 electrons in their valence shell. Okay, or duplet may be completed. In the case of helium, we can say. So, the remaining elements are not having 8 electrons or they are not octet completed in their valence shells and they cannot exist as independently. They will be existing as in combined forms. Okay, so the third statement can also be considered as a correct statement. Now, the remaining one is atoms aggregate in large number to form matter that we can see, feel or touch. Atoms aggregate in large number to form matter. Aggregate in large number that we can see, feel or touch. Okay. So, is it atoms? That is what I am going to ask you. Atoms aggregate. Aggregation means just grouping together, just coming together. There is no bonding or chemical force of attraction can be considered. So that is called aggregation. Are atoms aggregating into form molecules? To form matter? No. We can say that in order to form a matter or a substance, there must be the aggregation of molecules. not atoms. So this word should be molecules. Okay, molecules. So molecules aggregate in large number to form matter that we can see, feel or touch. That may be the correct statement, as here it is given as atoms. Atoms will not aggregate in large number. Atoms will combine together. 2 or 3 or 4 atoms may combine together through chemical bonding and forms molecules. And these molecules, this large number of molecules, for example, water molecules. Suppose I am asking you, if you are doubtful, hydrogen and oxygen are present. Okay, hydrogen and oxygen are 2 elements, 2 atoms. 2 hydrogen atoms and 1 oxygen I am taking. I am considering a group of these atoms. Will it make water molecule? Water? No. It should be, these atoms should be combined together and they should form H2O molecule, and aggregation of this H2O molecule may be forming the matter, the substance, water. So only if there is a combination or aggregation of molecules, a matter can be formed, right? So atoms are not the accurate, apt word here. Instead, we have to use molecules. Okay, so that is the 8th question. Answer option will be D option. Okay, so that is the incorrect statement regarding an atom. Now we are going to the 9th question. Okay, 9th question. An element X is divalent and another element Y is tetravalent. The compound formed by these 2 elements will be. So here we are provided with 2 elements. Which are the 2 elements? Okay, yes, X and Y are the 2 elements here. An element X is divalent. That means this element is able to deal with or react using 2 electrons. Okay, divalent, and another element is tetravalent. That means that element is dealing with 4 electrons, right? So divalent and tetravalent, that means valency of these 2 elements are given. The valency of X is 2 and the valency of Y is 4. That is what an element X is divalent means, and also another element Y is tetravalent means. Okay, the compound formed by these 2 elements will be, okay, which may be the compound formed here, or what is the formula of this, the compound which is formed as a result of the reaction between X, the divalent X and tetravalent Y. That is what we have to find out. Okay, if you are provided with such a question in your exam, what should be done at first? I think you can remember this. Okay, that means we will write the formula of the symbol of X, the elements X and Y first, and then we will write their corresponding oxidation states or valency. Here it is 2 and for Y it is 4. And then we will cross these valencies, right? So the number X, the number 4 will be written in as subscript for X and 2 will given for Y. Again I am writing X and Y. Okay, X and Y are here, and as subscript for X I will give 4, and as subscript for Y I will give a 2. So X4 Y2 will be obtained. Is there any such a formula here? No. So there is an option to simplify these 2 numbers. Using common factor, I am dividing these 2 numbers, right? So common factor may be 2. 4 by 2 and 2 by 2 I am writing. Now, what will be the result? X, Y, X, instead of 4 we can write here 2, and instead of 1 we can leave it. So X2, Y. Here blank means if we are not writing anything, there may be, that is representing 1. Okay. So X2Y will be the formula. Is there any such formula here? Yes, there is our option number 4, X2Y. So this will be the answer option for our question number 9. Okay. So 9th question, answer option is D. I think it is clear to you. Okay. Now going to the 10th question. Which of the following is a wrong combination? They are asking. Wrong combination. Among these combinations, we have to identify which is wrong. Okay. Now, how to solve this problem? First one is 6.022 into 10 raised to 23 molecules of oxygen is equal to 30 gram of oxygen. Is it correct? 30 gram of oxygen. That means 6.022 into 10 raised to 23 molecules of oxygen. We know that 6.022 into 10 raised to 23 means what? 1 mole. Right? 1 mole. So, 32 gram oxygen means, is it 1 mole? What is the molecular mass of oxygen? What is the atomic mass of oxygen? 16. So, 32 gram of oxygen is given here. Which of the following is a wrong combination? We have to choose whether it is correct or not. So, 6.022 into 10 raised to 23 molecule of oxygen means 2 oxygen atoms may be there. For 1 oxygen atom, we know that it is having atomic mass 16. Oxygen molecule means O2. O2 may contain 2 oxygen atoms and 2 oxygen atoms mass will be 16 into 2. That is 32. That is equal to 32 gram oxygen. Okay, 32 gram oxygen. 32 gram oxygen. So, this will be a correct choice. This is correctly matched, correct combination. Okay, so first option will be correct combination. And going to the second option, A. This is A and this is B. 6.022 into 10 raised to 23 ions of sodium. That means 23 gram sodium they are saying. 23 means the atomic mass of sodium. Okay, atomic mass of sodium. Na, sodium ion means what? Na plus ion. Here it is Na plus ion. Na plus means 1 electron lost from sodium. Is there any change in its mass number if an electron is leaving the atom? No, because mass number is number of protons and the number of neutrons. Here there is no change in number of protons or neutrons in this species. So, its atomic mass will not be changed and that will remain the same. As it is given as 6.022 into 10 raised to 23, okay, we can say it is 1 mole. 1 mole means its atomic mass. As Na plus ion is not having any change in its atomic mass, we can say 23 gram of sodium. Okay, 23 gram sodium, that is also correct option. This is also correct because there is no change in atomic mass, even though there is a release of energy. Not energy, electron, sorry. So, electron is lost from sodium and it forms sodium ion. Then its atomic mass will be the same. 1 mole sodium ion means 23 gram of sodium, no change. Because atomic mass is purely depending on number of protons and neutrons. Okay, so the second choice will also be correct. It is also correctly matched. Next is option C. We are going to option C. Okay, C. 6.022 into 10 raised to 23 atoms of carbon is equal to 24 grams of carbon. Is it correct? 6.022 into 10 raised to 23 atoms. Atom. Okay, atom means there must be atomic mass. But we know that atomic mass of carbon atomic mass is what? 12 gram. But here it is given as 24 gram of carbon. That is clear. What? 2 carbon atoms are present here. Okay. So, 6.022 into 10 raised to 23 means 1 mole. 1 mole carbon atom should be 12 gram carbon. So, it is given as 24 gram carbon. So, no doubts, definitely this will be our answer option as they are asking wrong combination. Okay. Now, going to option D, what happens? 6.022 into 10 raised to 23 atom of hydrogen is equal to 1 gram hydrogen atoms. No problem. 6.022 into 10 raised to 23 atom of hydrogen. That means 1 mole hydrogen. Mass of 1 mole hydrogen is 1 gram. No doubt. So, our answer option is C. Is it clear? Okay, yes. They are giving 6.022 into 10 raised to 23 carbon atoms of carbon. Its mass will be 12 gram. Because 6.022 into 10 raised to 23 is 1 mole. Mass of 1 mole carbon is 12 gram. It is given as 24 gram. There may be 2 mole carbon atoms. And to equalize this 24 gram carbon, here must be 2 into 6.022 into 10 raised to 23. Okay, I think you got the idea. C is the answer option here for 10th question, right? Now, going to 11th question. Number of moles present in 42 gram of nitrogen atoms are. Number of moles present in 42 gram of nitrogen atoms are. So, nitrogen atoms, they are considering nitrogen atoms. So, what is the number of moles present in 42 grams of nitrogen atom? So, we can use a relation. Number of moles, comma, it is represented as N, you know, is equal to mass in gram or given mass divided by, I think it is most appropriate writing given mass. That may be more clear to you. Given mass. Given mass divided by molar mass or molecular mass. Okay. So, number of moles present in 42 gram nitrogen atoms is. So, here instead of molar mass we can use atomic mass. Okay, molar mass or atomic mass. Atomic mass we can use. So, what is the number of moles? N is equal to what? N is equal to, given mass is 42 gram. 42 divided by, what is the atomic mass of nitrogen? Yes, that is 7. Not 7, but it is 14, sorry, 14. 14 grams. Atomic mass of nitrogen is 14 gram. So, we can solve this. Gram and gram will be cancelled. 42 by 14, that is equal to how much? Yes, 3. 3. So, number of moles will be 3. Is there any such option? 1 mole, 1.5 mole, 2 mole, 4.5 mole. No answer in this question, right? So, 3 will be the answer option here. Number of moles present in 42 grams of nitrogen atoms. Nitrogen atom. So, in 42 gram nitrogen atom, there should be 3 mole nitrogen atoms. But answer is 3 actually. There is no such an option in this question. So, you have to know how to solve such problems, right? Anyhow, there is no such an option. That may be printing problem. Okay. So, the important thing is you should be aware about how to solve such problems. You can use this equation. This equation is already discussed in the theory portions, right? So, answer option will be 3, okay, for 11th question. Not option 3, answer will be 3, okay, 3 mole, right? Next is, what mass of carbon dioxide will contain 3.011 into 10 raised to 23 molecules? What mass of carbon dioxide will contain 3.011 into 23 molecules? Okay, we know. What mass of carbon dioxide will contain 3.011 into 10 raised to 23 molecules? We know that. What? Molecular mass of carbon dioxide. Molecular mass of CO2 is equal to how much? Carbon 12, oxygen 16, 2 oxygen 32, 32 plus 12 44. So, 44 gram. This is the molecular mass, gram molecular mass of carbon dioxide. So, we know 44 gram carbon dioxide may contain how many molecules of carbon dioxide? Yes, 6.022 into 10 raised to 23 molecules. Okay, 6.022 Avogadro number of molecules may be there. But it is given as what is the mass of carbon dioxide that will contain 3.011 into 10 raised to 23 molecules. So from this expression, it is clear that if there are 6.022 into 10 raised to 23 molecules of carbon dioxide, it may contain 44 gram. So we can say one mass of one molecule will be what? 44 divided by 6.022 into 10 raised to 23, right? 6.022 into 10 raised to 23. Okay, so what will be the mass of how much? 3.011 into 10 raised to 23 molecules. So 3.011 into 10 raised to 23 molecules is equal to, we are multiplying it with 44 by 6.022 into 10 raised to 23. 44 into 3.011 into 10 raised to 23 divided by 6.022 into 10 raised to 23. So these two may be cancelled, right? Because 6.022 into 10 raised to 23 is a double of 3.011 into 10 raised to 23. 10 raised to 23 and 10 raised to 23 can be cancelled. 3.011 and 6.022 can be cancelled each other. So there will be what? This one and this one will be cancelled, and then we will get 2 here. 44 divided by 2, how much? 44 divided by 2 is equal to 22. So 22 gram. That will be the answer of that will be the mass of 3.011 into 10 raised to 23. So our answer option will be B, 22 gram. So 22 gram. Okay, so this is how we can solve such problems. We know first of all you have to compare the mass of molecular mass with the number of molecules, or atomic mass with the number of atoms. If atom is given. Okay, here it is given as half mole, 3.011 into 10 raised to 23. We know that 1 mole is equal to 6.022 into 10 raised to 23 grams, or 23 molecules, or 44 gram, and it is given as half mole, no doubt. So that may be 22 gram. Okay, so answer option will be B for our 12th question. Now going to 30th question. The formula of a chloride of metal M is MCl2. The formula of the phosphate of metal will be, okay, formula of the chloride of metal M is MCl2. MCl2. So here it is given as MCl2. This is the chloride of a metal, okay, metal chloride. And the formula of phosphate of metal will be, they are asking. So from this formula, M is a metal, chlorine is a non-metal, we know. But so we know that chlorine is from a halogen. Chlorine is a halogen. Its valency will be -1 always. Don't forget. So -1 here. Here it is given as Ex. So how can we calculate the valency or oxidation state of metal? We know from this formula itself, usually how we will write the formula, we will give M here, chlorine here, and valency of chlorine will be given here, and that of metal will be given here, and it will be crossed, right? So if it is X and a Y, we will write it as Mx and Cly. So this number will be corresponding to M actually. Okay, so from this formula, it is clear that 2 will be the valency of metal. So metal will be M2 plus here. Okay, and also there is another way I am telling you. That is why I am writing X and -1 here. So using this method, we can say that X plus -1 into 2, that is equal to -2, should be 0. The molecule should be electrically neutral. If we are adding all the valencies of the corresponding elements, there must be 0. it will be 0. So x is equal to how much? 0 plus 2. X is equal to plus 2. So that will be the valency of a metal. That is what we calculated by using this method also. So M2 plus. Now we have to write the formula of the phosphate of the metal. Okay, we have to write the formula of phosphate of the metal. Phosphate PO4 3 minus. Okay, phosphate PO4 3 minus. Phosphate ion will be like that. This is given in your textbook. Okay, there is a list of ions given. Also in the last part I told you about phosphate anion, polyatomic ions. Okay, so PO4 3 minus. Now we have to write the formula of the metal phosphate. So M here, PO4 here. Okay, 3 should be given here and 2 here. 2 means valency of metal. Now crossing these two numbers, we will get M3 PO4 twice. Okay, M3 PO4 twice, right? M3 PO4 twice. So is there such an option? MPO4, M3 PO4 twice, M2 PO4 thrice, M2 PO4. So no doubts, I think you got the answer, that is B option. Okay, option B is the answer option for our 13th question. Now going to question number 14. Which of the following contains the largest number of molecules? So 4 species are given here. Which among these contains the largest number of molecules? That is what we have to calculate. Largest number of molecules. Okay, present in. First one, A. Okay, A. It is given as 0.2 gram hydrogen. So we have to contain number of molecules here. 0.2 gram hydrogen. We know that 1 gram hydrogen is equal to 6. No, it is molecule, right? So molecules. So 2 gram. Molecular mass is 2 gram. 2 gram hydrogen may contain 6.022 into 10 raised to 23 molecules. So 0.2 gram may contain 0.2 gram. This is equal to Na, I am writing Na. Na means Avogadro number. Okay. So in order to calculate easily, we can use this for this large number. Okay. So 0.2 is equal to how much? 0.2 means 2 is divided by 10, right? So here also we are dividing it by 10. So it will be 0.6022. Instead we can write 1 by 10 into Na. Okay, 1 by 10 into Na. Molecules will be there in the first option. So we have to calculate the species having the largest number of molecules. Next, B. 0.8 gram oxygen. Okay, we know that 16 gram may contain 6 point, not 16 gram, it is molecule, right? So 32 gram we can use. 32 gram. 32 gram oxygen may contain 6.022 into 10 raised to 23 molecules. That is equal to Na, I am writing. So here it is 0.8. 0.8. So what will be the amount of oxygen, mass of oxygen in 8 gram? So 8 gram may contain 32 by 4 is 8, right? So 1 by 4 into Na. Okay, 1 by 4 into Na. So here it is 0.8 gram. So it should be divided by 10. So 0.8 gram is equal to 1 by 4 into 1 by 10. That is 1 by 40 Na. Okay, 1 by 40 Na. So here it is 1 by 10 Na molecules. Na means 6.022 into 10 raised to 23, right? In order to make it more easier, otherwise we have to solve, we have to divide it by 10, divide it by 4, so many calculations. So we can use this symbol Na. Avogadro number is represented by the symbol Na, N subscript A. Okay, so that is why I am writing 1 by 40 Na. Next option C. Okay, what about option C? 0.14 gram N2. We know that 14 gram N2 is equal to 14 gram corresponds to 6.022 into 10 raised to 23 nitrogen molecules, that is equal to Na molecules, right? Here it is 0.14. So 100 is to be used for dividing this value, right? So 0.14 means 14 divided by 100. So here also we have to divide it by 100. That is equal to 1 by 100 Na. Okay. So 1 by 10 Na, 1 by 40 Na, 1 by 100 Na. Next is D, 0.9 gram water. We know that 18 gram water, that is the molecular mass of water, is equal to 6.022 into 10 raised to 23 water molecules, that is equal to Na water molecules, right? Na water molecules. Okay. Now it is given as 0.9. So 9 gram will be equal to, 9 means 18 divided by 2. So 1 by 2 into Na we can use. 0.9, that means divided by again 10. So 0.9 gram is equal to, it corresponds to 1 by 20 Na. Okay. So now our question is, which of the following contain the largest number of molecules? Now I think it is easy to compare all, right? So here first option is 1 by 10 Na. Second is 1 by 40 Na. Third option is 1 by 100 Na. And the fourth option is 1 by 20 Na. Among these, it is clear that numerator is 1 for all cases, that is Na by 10, Na by 100. Let me write all together. First one is what? A, Na by 10. Okay, Na by 10. Second is what? Na by 40. 1 into Na means Na. So Na by 40. Next is Na by 100. Next is Na by 20. Can you say which among these will be the highest value? Numerators are the same. So we have to look on the denominators. Among these, the lowest value is corresponding to the highest number, right? So 10 will be the smallest denominator here, and that means Na is divided into 10 parts. Here it is meaning Na, that is a number divided into 40 parts. Here Na is divided into 100 parts. Out of these 100 parts, one part we have to consider. Here it is 20 parts. Among these, which will be the highest or largest one? Yes, divided by 10. So, no doubts, it is our answer option A. 0.2 gram hydrogen may contain largest number of molecules, right? So, this is how we can calculate. If we are using this Na instead of that number, it will be more easier. And if we are using this number, we have to divide it. We will get 0.6. Here it will be 0.6022 into 10 raised to 23. Or it can be written as 6.022 into 10 raised to 10. It is given upward and it will be 10 raised to 22. So we have to compare that large numbers. But I think it is easier way to compare such numbers, right? Same number is divided by 10, 40, 100, 20. No doubts, as numerators are the same, we can use the highest number as having lowest denominator. Which is the least number here? Na by 100, no doubt. So answer option will be A. Suppose if we are asking the smallest number of molecules, okay, then we can choose which option? Yes, Na by 100, that is C. C will be the answer option. It is having the lowest number of molecules. It is having the highest number of molecules, right? Okay. So 14th question, answer option is A, no doubt. Now 15, going to question number 15. The molecular mass of X is 106. X can be. There is a compound among these four which is having molecular mass 106. We have to calculate, or we have to find out which one is having molecular mass as 106. 106. Yes, here it is given 106. Okay. So first option is our calcium carbonate. Calcium carbonate, CaCO3. Option A. Atomic mass of calcium is 40. Okay. Plus 12 plus 3 into 16, that is 48. Right. So it is 0, 10, 0, 1, 9 plus 1, 100. So 100 came in my mind. That is why I written 40. Okay. So 40 plus 12 plus 48, that is equal to 100. 100 gram is the molecular mass of calcium carbonate. But here it is given as 106. So we cannot use calcium carbonate as the answer option. So going to B. SO2. Sulfur, it is 32 plus oxygen 16 into that is 32, that is 64 gram. So SO2 cannot also be considered, right? SO2 cannot also be considered. Next is C. Na2CO3. Sodium, it is 23 into 2, 46 plus 12 plus 48. So it is 10 plus 6, 16, remaining 1, 106, right? So answer option will be option C, that is our sodium carbonate. It is having 106 as its molecular mass. Once again, D option, NaCl, one more. That is 23 plus 35.5. That is equal to 0.5, 58.5. So that is cannot also be considered. So our answer option is C option. Sodium carbonate is having molecular mass 106. Okay, as given by the question. Next is 16th question. 1U or 1 AMU means what? 1U or 1 AMU means what? Atomic mass unit. No doubt, it is clear that 1 AMU is the 1/12th mass of a carbon-12 atom. It is known as 1 AMU. This value is used for comparing the atomic masses of other elements. This is used as a reference element, carbon-12. So 1/12th mass of a carbon-12 atom is considered as 1 AMU or 1 U. U means unified mass, AMU means atomic mass unit, both are the same. Okay, the percentage of hydrogen in water is, okay, so we can calculate the percentage of hydrogen. What is the molecular mass of water? Molecular mass of water, it is, we know, H2O, that is equal to 2 plus 16, 18 gram. From the molecular formula, it is clear that 18 gram water contains how much? 2 gram hydrogen. Okay, 2 gram hydrogen. So into 100 I am taking, then I will get the percentage. So 200 by 18, or we can write 100 by 9. Okay, so it will give 11.12% as the answer option. So 11.1 or 12. So our answer option will be B, no doubt. So you can solve this. 100 is divided by 9 and we will get 11.12. So this is how we can calculate the percentage of hydrogen or any element in any compound. First of all, you have to calculate the molecular mass, then take the total mass of the elements whose percentage is to be calculated and multiply it with 100. So in that way we will get 11.12%. Okay, so that is about our 17th question. Now going to 18th question. Question number 18. When an atom loses electrons, it is called an or a what? If it is losing an electron, it may be a cation. Okay, no doubts. And has a positive charge. Not change, it is charge. Okay, so there is a positive charge. So cation positive, which is the option? Yes, B, option B. Okay, it is an easy question. Next is mass of 9.033 into 10 raised to 23 methane molecule is. So what is the mass here? Here it is given as the number of methane. So we have to calculate the mass, right? So we know methane, CH4. Its molecular mass is 12 plus 4 into 1. That is equal to 16 gram. It is a molecular mass of methane. We know that if it is 16 gram, it may contain 6.022 into 10 raised to 23 methane molecules. Okay, it is given as 9.033 into 10 raised to 23 molecules. So we have to calculate its mass. So I am reversing this equation, that is 6.022 into 10 raised to 23 CH4 weighs. That means the mass or weight of 6.022 into 10 raised to 23 methane is equal to how much? 16 gram. Okay. So what will be for for one methane molecule? One methane molecule is equal to 16 divided by 6.022 into 10 raised to 23. Okay. Here it is given as 9.033 into 10 raised to 23. That is equal to 16 into 9.033 into 10 raised to 23 divided by 6.022 into 10 raised to 23. Okay, so what will be the solution here? If it is dividing, cutting, 10 raised to 23 and 10 raised to 23 can be cancelled. Okay, no doubt. So 9 by 6, we are cutting it with 3. Okay, I will get here 2 and it will be 3. Okay, right? 3 by 2. So 16 and 2 are cancelled. So we will get 8 here. So it is 24 gram. Yes, 24 gram. Okay, so here the question was 9.033 into 10 raised to 23 methane molecule, its mass is to be calculated. Is there any option? Yes, 24, our option is A, answer option. So, the way by which we calculated the mass was that I considered a molecular mass of methane at first. We know that 1 mole or 6.022 into 10 raised to 23 methane molecule weighs 16 grams. Actually, this 6.022 into 10 raised to 23 is related to 9.033 into 10 raised to 23. In what sense? Yes, there is only a small difference, that is 3.022 into 10 raised to 23. So that is how here 3 came, and this is a unitary method. This is how I calculated. You can follow this method also without any confusion, right? So this is called a unitary method. We know that 6.022 into 10 raised to 23 methane molecules weighs 16 grams. Then what is the mass of one molecule of methane? Because here number is given. Okay, and that is why we are using the number itself. So 6.022 into 10 raised to 23 methane molecules weigh 16 gram. Then one molecule will weigh 16 divided by 6.022 into 10 raised to 23 grams. Then it is given that 9.033 into 10 raised to 23 molecules of methane. So we have to multiply this with the 9.033 into 10 raised to 23, and we can cancel it out, and we will get the answer 24. So answer is our A option, 24. Okay, so for 19th question, answer option was 24 gram. That is A option. So going to 20th question, the formula of nitride of metal is Xn. The formula of metal sulfate is. So nitride, the formula of a metal nitride. So metal is X here. Metal nitride is Xn here. Okay. So what will be the formula of metal sulfate? That is what we have to calculate. We know that Xn stands for the metal nitride, and the formula of metal sulfate is nitrogen is having valency -3, we know, nitrogen, because atomic number of nitrogen is 7. Okay, its electronic configuration is 2, 5. So nitrogen needs 3 more electrons. Okay, 3 more electrons needed by nitrogen. And so it may have -3 as the oxidation state or valency. We have to consider the valency of X then. Okay, so nitrogen is -3. Then what will be for X? X I am writing small letter x here, N -3. Okay, So that is equal to 0. We can no, that is not equal to 0. We are adding the charges here. X plus minus 3 is equal to 0. So that is a fact, general fact, right? In every compound, the total charges of the ions present should be 0. Okay. For example, I am taking NaCl. We know that it is Na plus and Cl minus. Plus and plus 1 and minus 1 will be there. So plus 1 plus minus 1 is equal to 0. Okay. So for every compound we can use. And also calcium carbonate, CaCO3. Here it is 2 plus and 2 minus. CO3, 2 minus. So plus 2 and minus 2 will be 0 sum. So in that sense we can write then x plus minus 3 is equal to 0. So x is equal to plus 3. So valency of x is plus 3. Here we have to write the formula of its sulfate. Okay, sulfate. So I am writing x here and SO4 2 minus here. Here for x we can write plus 3 or 3. So crossing these values we can write x2 SO4 thrice. Okay, x2 SO4 thrice. And this will be the formula here. Can you say the answer option now? Yes, x2 SO4 thrice. Answer option will be A. Okay, A is the answer option. For 20th question, answer option is A. Okay. Now, going to 21st question. The molecular mass, molecular formula of magnesium nitrate is magnesium nitrate. How to identify the molecular mass? So, the elements are magnesium and nitrate ion, NO3. Okay. We know that the magnesium is from second group. Magnesium is having valency plus 2, Mg2 plus. It will always have valency plus 2. That you should keep in your mind. That is a general fact. S block elements, that is our group 1 and group 2 of the periodic table, may contain constant valency. That means for first group, their valency will be plus 1. Don't forget, in every compound, they will be in plus 1 oxidation state or valency. That means they can release only 1 electron. In the second group, we can consider plus 2 as their valency because they can release 2 electrons. So, Mg magnesium 2 and NO3 minus 1. So, 1 here. Okay. So, crossing these values, we will get Mg NO3 twice. Is it correct? Which is the answer option? Yes. MgNO3, Mg2NO3, MgNO3 twice, Mg3NO3 twice. Which is the answer option here? MgNO3 twice. Yes, our C option. Answer option is C. MgNO3 twice will be the answer option. That is option C. I think it is clear to you. Magnesium is assuming plus 2. It will always be the same for second group elements. Beryllium, magnesium, calcium, strontium, barium. All may have 2 as plus 2 as valency. Lithium, sodium, potassium, rubidium, cesium all have plus 1. No change. So that is how we can assume it. NO3 is a polyatomic ion. It is given in your textbook. There are certain examples as given as a table. Okay. So from that you will get. So by writing the formula, by following the rules for writing the formula, we can reach this formula MgNO3 twice. Okay, so answer option is C. Going to 22nd question. Which of the following represent a correct formula? Correct chemical formula. Which of the following represents the correct chemical formula? So calcium chloride, Na3SO4 twice, Na2S, Al2O3. So our 22nd question. Okay. Let us see. Which of the following represent the correct chemical formula? Okay, so first one is calcium chloride. Calcium chloride. Here the elements are calcium and chlorine. Let us check. Calcium may have oxidation valency plus 2, we know, plus 2. Chlorine minus 1. So crossing these CaCl2. This should be the correct formula for calcium chloride. So it is incorrect. CaCl is given. It should be there. Okay, CaCl2. But it is correct. It is incorrect. Na3SO4, sodium, then SO4. SO4. We know sodium plus 1, SO4 2 minus. Okay. So there must be Na2SO4. Na2SO4. Is it correct? No. No, it is also incorrect. Okay, Na2SO4 should be there. I told you sodium is from S block first group, calcium from second group. Okay, so that is incorrect. And the C option, Na2S, sodium, sulfur. Okay, sulfur is in 16th group, its oxidative valency will be -2 or 2. Sodium +1 we can say. Crossing this, Na2S. Yes, it is correct. So our answer option is option C. Okay, and then Al3O2, AlO, 2 oxygen -2 and aluminium +3. So crossing this, Al2O3 should be there, but it is given as Al3O2. So that is incorrect. Okay, that is incorrect. There is another way also you can check. Calcium. Calcium we know 2 plus, so +2 plus. Chlorine we know -1, so -1 should be 0. Is it equal to 0? +1 and -1 +1. Sorry, +2 plus -1 +1. So this is not equal to 0. So this may not be correct formula. Here it is Na plus in +1, +1 into 3, +1 into 3, 3 plus. Here it is -2 into 2 +4. Is it equal to 0? Sorry, -2 into 2 -4. So here it is -1, that is not equal to 0. Na2S, that is +1 into 2, 2 plus sulfur -2 is equal to 0. Yes, it is equal to 0. Aluminium +3 into 3, 9. 9 plus oxygen -2 into 2, -4. That is it equal to 0? Not equal to 0. So in that way also we can identify whether the given formulae are correct or not. So here the answer option is C, no doubt. Second, 23rd question. Which of the following pair of atoms of elements represent the mole ratio 1:1? So they are given 20 gram of sodium, 20 gram of calcium. So here 1:1 ratio in terms of mole we have to calculate. So 20 gram sodium and 20 gram calcium. 20 gram sodium and 20 gram calcium. We know that mole ratio is calculated. Okay, so it is 20 gram sodium. 20 gram sodium means what? How many mole? We know that 23 gram sodium means 1 mole. So it is not 1 mole. Okay, sodium, its atomic mass is 23. 23 is the atomic mass of sodium. So here if it is 23, we can say it as 1 mole. For calcium means 20, we know that is 1 mole. So it is not equal to 1 mole, but it is 1 mole. So it is not to be considered. I think it is clear to you. Once again I am repeating. For this question, you have to know the atomic masses of elements. Okay, sodium atomic mass is 23. If it is 23 gram, we can choose it as 1 mole. Calcium is atomic mass is 20 gram. That is equal to 1 mole. If here it is 23, we can choose it as 1:1, molar ratio 1:1. But here it is given as 20. So it is not 1 mole. So first option cannot be considered, right? In the similar way, I am continuing. 7 gram of nitrogen. Yes, that is 1 gram nitrogen atom. 12 gram of sodium. Sodium's atomic mass is 23. So it may not be 1 mole. So this cannot also be considered. This can be considered 1 mole nitrogen atom, but it is not 1 mole sodium atom. Okay. 10 gram of calcium and 6 gram of carbon. 10 gram calcium. 10 gram calcium means what? Half mole, right? Half mole calcium. We know that calcium's atomic mass is 20 gram. It is given as half. 20, half of 20 is 10. So half mole. Carbon, we know 12 gram is atomic mass of carbon. That is 1 mole. But it is given as 6 gram. Half of 12. So that will be half gram. So, half mole. So it is half mole. If we are taking the ratio, half is to half, that is equal to 1:1, right? Both are equal. So 1:1 ratio here. 28 gram of nitrogen, that means 2 mole. 2 mole nitrogen here. Because 14 is the atomic mass of nitrogen and 28 is the twice. So 2 mole. 24 gram of magnesium. Magnesium atomic mass is 24. Yes. So it is 1 mole. It may not be 1:1 ratio. 1:half we can consider. So 1:1 ratio is obeyed by C option, and that is why the 23rd question may have C as the answer option. 10 gram of calcium and 6 gram of carbon. Okay, going to 24th question. Question number 24. A student heats 25 gram of reactant A with 50 gram of reactant B. He obtains 50 gram of product C and recover 25 gram unreacted B. Which of the following law is confirmed by the following reaction? Okay, so the question is, a student took a 25 gram reactant A. A and B are two reactants here. Okay, A and B are two reactants here. And after this reaction, we are getting C as the product. So a student heats 25 gram of reactant A. He took 25 grams of A and 50 grams of B. 50 grams of B he took. And he obtains 50 gram of product. 50 gram product C and recover 25 grams of unreacted B. So here total total mass of reactants is 75 gram, we know, but the product formed is 50 grams. It is also said that the student recovered 25 gram unreacted B. So we have to minus 25 from here. So we will get 50 gram. Okay, so now the total mass of reactants reacted will be equal to 50 gram. Product formed is 50 gram. So both of these two are balanced. 25 gram of the reactant B is recovered. So if we are considering 25 gram here instead of 50, 25 plus 25 is equal to 50. So 25 is recovered, they are saying. So which of the following law is confirmed by this reaction? Law of constant proportions, law of conservation of mass, law of conservation of mass and law of constant proportion, law of multiple proportion. Yes, it is law of conservation of mass. Okay, so law of conservation of mass is confirmed here because there is nothing telling about the ratio by mass of these two elements in that product. So here it is A and B. These two are reacting together. C is getting. There is nothing about the formula or chemical molecular formula. We have only then we can identify whether it is confirming law of constant proportion or not. But here nothing is mentioned about the composition of the reactants or product molecules, elements in the reactants or products. So it is law of conservation of mass. It is clear that 25 gram of A is reacting with the 25 gram of B and we are getting 50 grams of C. Because how we came to know 25 gram of B is reacted, it is given here. He recovered 25 gram of unreacted B. And that is why. Okay, so answer option is B here. 25th question. Number of atoms in 46 gram sodium is. We know that 23 gram may contain 6.022 into 10 raised to 23 sodium atoms. So what is the number of molecules, number of atoms in 46 gram? So we have to take 46 here is equal to 2 into 6.022 into 10 raised to 23. That is equal to 12.044 into 10 raised to 23. Answer option will be B. That is twice of 6.022 is to be considered. Okay. So answer option is B here. Now going to 26th question. Number of moles of oxygen atoms in 2 moles of nitric acid is. We can see nitric acid is HNO3. So what is the number of moles in 1 mole? In 1 mole, this formula represents 1 mole nitric acid. Okay. In 1 mole contain 3 mole oxygen. Okay. So how many moles in 2 moles? 2 mole. Will give 2 into 3. So 6 mole. 6 mole oxygen. So answer option is D. Okay. Answer option is D here. If they are asking hydrogen, 2 mole will be there. Nitrogen, 2 mole will be there. So here it is oxygen. So 6 mole. Okay. Going to 27th question. Calculate the formula unit mass of magnesium chloride. Formula unit mass, we know that it is used for ionic compounds, right? So here it is MgCl2. Mg2 plus and Cl minus ions are there. Magnesium is having 24 plus chlorine 2 into 35.5. That is equal to 24 plus 71. That is equal to 24 plus 71. So 95. So answer option is D. 95. So answer option of 27th question is D, right? Next is 28th question. Which of the following does not represent a molar mass of a substance? Molar mass of a substance, which is not does not representing 1 mole HCl. Which of the following does not represent a molar mass of a substance? Molar mass means what? Molecular mass or mass of one molecule. 1 mole HCl, we know that it is 36.5 gram HCl, that is 1 mole, correct? 6.022 into 10 raised to 23 molecule of helium. Molecule of helium, okay, molar mass. Helium is in atomic form, we know. It will never form a molecule, right? So 6.022 into 10 raised to 23 molecule or atom can be, both terms can be used for helium. It always exists as He itself, no He2. Okay, so the number will be the same. 6.022 into 10 raised to 23 may contain He molecules. Its molar mass can also be considered like that. Such a number may contain its molecular mass or molar mass, no doubt. 16 gram of O2. We know that atomic, this is in molecular form. Oxygen is having 16 gram as atomic mass, but O2 is having 32 gram. So it should be 32. So molecular mass of oxygen is 32. So molar mass or molecular mass should be 32. So as it is given as 16 gram here, C option may not be correct. So our answer option will be C here. 44 gram of carbon dioxide, that is correct. 12 plus 32, right? That is equal to 44. Correct. So answer option for the 28th question is what? C. 62 gram should be there. Which of the following does not change when chemical reaction takes place? Volume, physical properties, mass, chemical properties. Which of the following does not change when a chemical reaction takes place? Suppose a chemical reaction is taking place. That means two reactants are reacting together to give products. Or a compound is decomposing to give two products. Like that. Suppose we are taking A and B are reacting to get C, or AB is splitting into A plus A and B. Which of the following does not change when a chemical reaction takes place? They are asking. Volume, physical properties, mass, chemical properties. Okay, so which will not change? Volume may change because suppose a solid is converted into liquid. Otherwise, two gases we can say. Hydrogen and oxygen, simplest example. H2 plus O2. We will get H2O. Okay, 2H2O. Here hydrogen and oxygen are two gases. They are having a large volume. But these two are combining together to get water. That is a liquid. It will be having lower volume than the reactants. Right? No doubt. Volume will change as a result of chemical reaction. Physical properties may also will change. Here it is gases, liquid. Gases are converted into liquid. Physical change that may occur. But mass, what is the mass of hydrogen here? 2 into H2, that is H2 is 2, 2 into 2, 4 gram. Oxygen, 32 gram. So total is 36 gram. We know that molecular mass of water is 18 gram, 18 into 2, that is equal to 36. So mass remains constant. Chemical properties may also change because hydrogen is a combustible gas. Oxygen is a supporter of combustion. But water is fire extinguisher. So this may also change. Answer option is C. So 29th question, which of the following does not change when a chemical reaction takes place? The answer is mass will always be the same. That is what we are saying, law of conservation of mass. Okay, so answer option is C here. Now going to the last question. Number of atoms present in 0.5 mole nitrogen atoms is same as in. Number of atoms present in 0.5 mole nitrogen atoms is same as in. So first of all, we are going to calculate the number of atoms present in 0.5 mole nitrogen atom. 1 mole nitrogen atom is equal to Na atoms, right? Avogadro number of atoms may be there. In 0.5 mole nitrogen is equal to 1 by 2 Na, or Na by 2 we can say atoms. Okay. Now, option A, 24 gram of magnesium. 24 gram magnesium. 24 gram is the atomic mass of magnesium. That is equal to Na atoms. Is it equal to 1 by 2 Na? No. So, it may not be the answer option. Okay. It is Na. We can write it as Na. Na. Okay. Next is option B. 32 gram of sulfur. 32 gram of sulfur is equal to sulfur. Atomic mass is 32 itself. So, it is also Na. Okay. Avogadro number of atoms may be there. Avogadro number of atoms. That may not be Na by 2, half mole. It is 1 mole. Okay. Now going to option C. 12 gram carbon. It is also equal to Na atoms. Right? Na atoms. Okay. 12 gram carbon means Avogadro number of atoms of carbons are there. Carbon atoms are there. So, it is also equal to Na. It is also equal to Na. Okay. Now, going to the last option, D, 8 gram oxygen is equal to. We know that 16 gram oxygen, if it is 16 gram oxygen, it will be Na. But it is given as 8 gram, half of 16. So, it will be Na by 2 or 1 by 2 Na. Okay, so it is 1 by 2 Na, which is equal to 1 by 2 Na. That is answer option here. Here it is nitrogen is 1 by 2 Na and oxygen is also 1 by 2 Na by 2. So, number of atoms present in 0.5 mole nitrogen atoms is as same in what? Which option we can choose? Yes, option D. That is 8 gram of oxygen. Both of these are having what? Equal number of moles of atoms. So, D is the answer option here. So, this is all about the questions of our chapter atoms and molecules. I believe all these questions were clear to you. Okay, if you are facing any doubts, you can contact. Okay, so study well and read the text carefully, thoroughly, and prepare for the examinations. Okay, so I think it is time to wind up this part of our class, and all the best. Thank you.